right, let's get right into it. Today, we're going to get under the hood of one of the most powerful and, let's be honest, talked about technologies out there, large language models. You probably know them as LLMs. So you've almost certainly seen tools like ChatGPT do their thing. And it feels kind of like magic, right? But it's not. The real question is, how does it actually work? How can a machine generate text that feels so human? Well, that's exactly what we're going to break down.
Okay, so to really get how an LLM can write an email, or a poem, or even a chunk of computer code, we first have to understand what it's made of. We have to start with the absolute basics, the building blocks. So everything really kicks off with something called a foundation model. Just imagine an AI that's been given a library the size of a planet to read, but with no specific job to do. It hasn't been taught one particular skill. Instead, it's just learned to see the patterns in, well, everything. And that's what makes it so incredibly flexible. Now, a large language model, our LLM, is a type of foundation model that's basically been sent to a specialist school. And its one and only subject? Human language. It's been specifically trained to get the hang of all the nuance, the grammar, and just the general flow of text and conversation. And when we say text, we mean all of it. A huge chunk of the internet. Millions of books, articles, online conversations. But here's the really cool part. It also learns from computer code. And this is so important because code is just a super structured kind of language. It teaches the model all about logic and reason.
So let's talk about that first word, large, because honestly, that one word is doing some serious heavy lifting here. The scale we're talking about is almost impossible to wrap your head around. But hey, let's give it a shot.
The GPT-3 model, for example, was trained on 45 terabytes of text. Just let that number sink in for a minute. 45 terabytes. To try and put that into perspective, a single gigabyte of text is about 178 million words. And a terabyte is 1,000 gigabytes. We're talking about an amount of information that is it's on a completely different level. But large isn't just about the data it eats. It's also about the model's complexity, and we measure that in something called parameters. The absolute best way to think of a parameter is like a tiny little knob that the model can twist and adjust on its own as it learns. The more knobs it has, the more nuanced its understanding can become.
So how many of these little knobs does a model like GPT-3 have to play with? 175 billion. That's 175 billion different variables it can tweak to refine its understanding of language. That sheer, mind-boggling complexity is where all the power comes from.
Okay, so we've got this insane amount of data and an AI brain with 175 billion little dials. But how does it actually learn anything? Well, believe it or not, it all boils down to a surprisingly simple three-part engine.
It's kind of like a recipe with three main ingredients. First, you start with that massive library of data we just talked about. Then you need an architecture. That's the neural network, the digital brain to process it all. And then finally, you've got the training process. And this last part, this is where the real learning happens. Now, the big breakthrough architecture behind most of these new LLMs is something called the transformer. And its superpower, really, is understanding context. It's what lets the model know that the word bank means something totally different in riverbank than it does in money bank. It sees how all the words in a sentence relate to each other.
And here is the most wild part of this whole thing. For all the talk about complexity and billions of parameters, the model's number one job is shockingly simple. Just predict the next word. That's it. It's essentially playing the world's most sophisticated game of fill in the blank. So at the very beginning, its guesses are complete nonsense. It'll say something like, the sky is bug. But every single time it's wrong, it goes back and nudges those 175 billion knobs just a tiny bit. Now, you repeat that process billions and billions of times, and it starts to learn that the word that's most likely to come after the sky isn't bug, it's blue.
After all that general learning, the model can be fine-tuned. This is like taking a general practice doctor and sending them to a specialized school to become a brain surgeon. You train it on a much smaller, specific data set to turn it into an expert at one particular task, like writing Python code or answering customer service questions.
So, that's the theory. That's what's happening behind the curtain. But what does all this actually look like out here, in the real world? How is this tech being used right now? Well, you're already seeing them everywhere, from those customer service chatbots that can actually solve your problem now, to tools that help you write articles and emails in seconds. And they're a huge deal for software developers, helping them generate and review code way faster than before. And really, that says it all. As impressive as all these applications are, they're just the first wave. We are only just starting to figure out what's even possible with this technology. So that leads to the big question, right? Where does all this go from here? Because this field is not standing still for a second. In fact, it's evolving faster than almost any technology we have ever seen. As these models just get more and more powerful and efficient, the possibilities they explode. Think about things like accelerating drug discovery, creating brand new materials, or even composing music. What felt like pure science fiction just a couple of years ago is on the verge of becoming our everyday reality.
So I guess the question for all of us is this. As this incredible tool becomes more and more accessible, what new problems are we going to solve with it? In science, in art, in our daily lives. The future is being written as we speak, and there's a pretty good chance an LLM will be helping hold the pen.